Welcome to Rob's Fix-A-Chop. So something that's been bugging me for a while is, so I've got this nice old HP meter. Come on. Okay, well, it does have some problems, right? And it's got a continuity checker, right? So I change it to ohms. Then I hit select. And then, right? And I listen to this. I can barely hear it, right? I can barely hear it. And then when I'm trying to do other stuff, and I'm trying to check continuity, I want to be able to see a very obvious indicator that I've got continuity, right? So I started going around and looking for to buy a continuity checker, and it was really difficult because you can't find. I just didn't. There was a lot of them, but a lot of them were for kind of industrial, line voltages, and I wanted something that would be good for the shop, that would be indestructible, that I wouldn't have to worry about very much as far as a battery. And I found a guy who, unlike me, seems to be an electrical engineer, and he designed a circuit that I think did everything I wanted. It had protection so that if you actually hit a voltage, it wouldn't hurt it. It shines an LED. It has a buzzer. It has everything I needed, right? But the circuit board that he had, he used the through-hole components, and I decided that I wanted to use surface mount components, put that into Easy EDA, drew the circuit out, and had a board built. And so I wanted to go through today putting that board together and talking a little bit about the circuit and just seeing how well it came out. So if you're interested, hang on. I think it's going to be kind of fun. If I can actually come up with something, I'm not doing it for cost because those boards are really inexpensive to have done, but by the time you get the case, the board, the wires, and the parts and everything like that, it gets to be a lot of expense. But I don't know, I thought it'd be fun to have a really good continuity tester. So if you're interested, hang on and we'll get this thing together. So here's the video I watched to kind of figure out how to do this, and it's called the Ultimate Continuity Tester, and I'll put the link down below because I think it's just a great video, and he does just a really good job of explaining the engineering behind the continuity tester. The channel is Leo's Bag of Tricks, and so yeah, be sure you take a look at that and watch that video. It's really good. So first let me show you how the circuit actually detects continuity. So we have this transistor up here. Whoops. We have this transistor up here, and what happens is when you connect the probes across, you have continuity, then you're going through some stuff, but you're really connecting the base to ground, and then that turns on current flow through to the LED right here. The LED comes on, and then you come through here, and then you power the op amp, right? So the op amp is off initially, but then as soon as you have continuity, connect this through to ground, then your op amp comes on, right? And your op amp is acting as a comparator, and it's comparing between this kind of the voltage divider and what's coming through here, and comparing them, and then it turns on this transistor here, which connects the buzzer through to ground, right? And so then the buzzer comes off. So this is doing the fine detection, right? This is like making it so that you're detecting at around 5 ohms, but like this up here, that's detecting at a much larger level. So one of the really cool things about this circuit is how it does protection, right? And so right here we've got, so we're going to be, like I say, we're going to be dumping current up through here into this base, right? And so let's say we actually have a circuit that's energized, right? So let's say we've got a really big swing here. what's going to happen is that when we're on the upswing here, this diode here is going to protect anything from going through here, right? And then the same is true here. This diode here and this diode here are going to be protecting the circuit, right? The problem is that when you have the downward flow, this diode is not going to be able to do the protection, right? Here it's fine because we're going through this one meg resistor, and actually there should be two resistors here, two 500s, so that we can handle the higher voltages, but I screwed that up. The original circuit had two 500K resistors, but we've got this thing, this TBU1, and it's actually like a little circuit breaker made up of kind of internally of a couple of MOSFETs, and it's actually meant to protect circuits from voltage spikes, and so that this in here protects the circuit from over voltage, because if we had too much of a negative swing coming through here, right, we would cook everything in the way here, everything throughout here, right? And so this is what's going to protect this this continuity checker, so that if you do actually touch like a capacitor that's charged, or a AC line or a DC line, it's going to protect the circuit so that you don't have to worry about it. So I designed my board. So here's my board, right? And seriously, they're just a couple of bucks. So once I'd drawn that schematic, then I could convert it over to a board. And so I had these cases. So I want this to go in here. And then I want the battery to kind of go in here, right? And so this is a battery that it's 3.7 volts, which might be kind of a lot for this application. I want that to go in here. Then I want this to kind of come so I can charge it, and then the whole thing then will go in here. And I've got my buzzer and my LED right here, so hopefully I can just drill something in the top here so I can hear it and see it. And I don't know. That's my next step, is to get all this stuff together. I've got my parts here, and so yeah. So now I just got to start soldering parts on. All right. So I'm just putting this solder paste on, and this works really nice. Kind of like just kind of dabbing it on like that. Alright, put the parts on there. Alright, well there it is. I've got all the parts on. Now I'm going to get my heat gun and see if I can start sticking them on. Yeah, so it looks pretty good. I thought there's a couple places where I used a little bit too much of the solder paste, but otherwise I think it went really well. And worked pretty good to put everything on there first and then heat it up, because then the heat would kind of heat up other parts of the board, and the other pieces would, you know, come together. So I'm going to put the buzzer on and the LED, and we can give it a test. Okay, so here's the circuit here, and you know, I had a few problems that I fixed. I had a couple diodes reversed, and I have mine hooked to 3.7 volts, but the original circuit that I got was 3 volts. Just because the battery I'm using produces 3.7, so I have my power supply set to that. So it works pretty great, and so that you can see, so if I put my probe on the power to the op amp, right? Whoops, I guess I don't have that. To the op amp's off. And then when I have continuity, then it actually powers the op amp. So that's pretty cool, right? And let's see. Okay, so I wanted to kind of check what where it starts actually doing the buzzer, right? So if I have like a 220 ohm resistor here, right? I'm turning on my power, but I'm not doing my buzzer, right? So I want to see where it's actually coming on. So I've got this little potentiometer here, and I'm going to hook it up, and we'll just see where it starts coming on. Okay, so there it is, powered. See, it's got a really nice threshold too. Okay, so let's check what that is. Turn that off so it doesn't wreck my hearing. We'll go to ohms. And yeah, so we're coming on right at about 3.5 ohms, which is exactly what the circuit was designed for. Okay, so next I want to start kind of building my case. I got one of the circuit boards I didn't use. I'm just going to use it to draw in my, where I need to drill in here, and then yeah, I'll have to figure out how to mark this top part here for where to drill for the speaker and the LED. Then I got some pretty red LEDs I think will look a little bit nicer. And yeah, so let's start marking those holes. And I've got these standoffs here that will bring the board up. To about there. I think that'll be fine. So, yeah, so I'm going to go out and drill these, and I'll be right back in. All right, change of plans. So I was originally thinking that this would just fit right into the circuit board, right? But if I raise this up high enough that these are kind of visible through the lid, like that, which I like, right? Then this is kind of floating in space here. And so I think what I'm going to do is I'm just going to take the battery and just kind of put it in here. And then this will go on top. And I'll just have some leads soldered to it. I think that's going to work just as well. And then it's going to be easier for me to put the hole in here to for the charger. Yeah, because this has a little charging port on it. And I think we should be good there. Yeah, so I just got to get a hole in here. Oh, that's looking pretty good. Make it a little bit bigger though. Okay, looks good. So I'm going to solder right onto the top of this battery, and it's got this kind of weird coating on it. So I'm just going to sand that off and see if it solders a little bit better. Okay, so for doing this, we want to put solder on there quick, right? And so I'm just going to, so I've got this big soldering iron here, and I'm just going to right, and then cool it off with a little alcohol, right? And then perfect. Cool it off. Then we got to do the other side. Okay, so I got those two holes drilled, and I don't know, it was a little dicey. I got this one off a little bit, so I had to like make my holes a little bit bigger so I could slide this board around. But whatever, it's there. Yeah, I think it's looking pretty good though. So now I just have to drill a hole in the end, and so I just bought some inexpensive probes, and I'm just gonna clip those ends off and you know, put a hole in here and feed them through, and then I think we're ready to give it its maiden flight. All right, so let's get it a little head-to-head test, right? So here's my meter, which I just love, but okay, so if I want to check continuity, flip it on, go to ohms, go select, right? And then barely hear it, right? Now let's try this one. Much better. All right, I'm happy now. And then to charge it, then you just plug a charger into here. And although I don't think it'll need to get charged very often, right? But yeah, that's cool. So one of the things that's really cool about the circuit is how much protection it has to protect the circuit. So let's say common thing we're doing with the continuity tester, just making sure that our power cord is where we think it is, right? Works great for that. But let's say we have this plugged in, which is bad, right? What happens when we take this probe and this probe and touch them? Still works. It still works fine. It's not bothered by that high voltage. Now, if you're in an amplifier, like a guitar amp where you've got 460 volts, that's a little dicier, right? I don't know. But yeah, for now it works great. So I'm really happy with it. So that's it for Rob's Fix-It Shop. I hope you liked it. I really like this continuity checker. I never have to turn it on. It just comes on when I go like that. It's got a nice 5 ohm transition, which I like. Nice and simple. Should rarely ever have to do anything other than grab it and go. So yeah, so I had fun putting it together. If you had fun watching it, hit like and subscribe, and thanks for watching.